In this video, I will explain how to find the least common multiple with variables. So let's check out a few examples. Let's say we have the term 10ab cubed and the term 4a squared b squared. How can we find the least common multiple between these two terms? Well, the first step is we just want to focus on the numbers, 10 and 4. How can we find the least common multiple between 10 and 4? Well, one way to do it is to perform prime factorization, and that's where we break down each number into factors until we're only left with prime numbers. So let's do that for 10. We can break that down into 5 and 2. And notice that both 5 and 2 are prime numbers, so we're actually done with the prime factorization right there. So the way that we can write this is with exponents. So we say 5 to the first because 5 only occurs one time. And then we say 2 to the first as well because 2 only occurs one time. Okay, now let's look at the 4. Let's break that down into factors. So we could say that's 2 times 2. And notice that 2 and 2 are both prime, so again, we're done with prime factorization right there. So how can we write this in exponential form? Well, we would say 2 squared, because the 2 occurs 2 times. So the last step is we want to identify each unique number. So here's a 5, here's a 2, and here's a 2. For each unique number, we want to choose the one with the highest exponent. So for the 5, there's only one 5 that occurs right here. So we just have to choose that one. So 5 to the first. But notice that here's 2 to the first power, and here's 2 to the second power. Well, this exponent is greater, so we'll choose this one. So what we do is we say 5 to the first times 2 squared. So 5 to the first is 5, 2 squared is 4, so 5 times 4 is 20. So 20 is the least common multiple between 10 and 4. And prime factorization is how we figured that out. Another way to figure that out, if you really wanted to, is you could just write out multiples of each number, so 10, 20, 30, 40, those are multiples of 10. And if you wanted to write out the multiples of 4, 4, 8, 12, 16, 20, 20 is the first value that occurs in both lists. So that's the least common multiple between them. So that matches the answer that we got here. Prime factorization was just kind of a shortcut way to do that instead of listing out all these numbers. So just keep that in mind. Okay, next we move on to the a's. So here we have an a and here we have an a squared. The least common multiple between them is simply going to be the one with the higher exponent. So it's going to be the a squared because this has a higher exponent. So let's go ahead and just underline that. And next we'll move on to the b's. So we have b cubed and b squared. So which one has the higher exponent? Well, it would be this one, b cubed. So b cubed is the least common multiple between b cubed and b squared. And if you want to think about that, b cubed is really just b times b times b. And b squared is just b times b. So we can see that the least common multiple between these two would have to be this first term because the b times the b can go into it. And the b times the b times b can just go into itself. So the least common multiple between them is just this b cubed right here. Okay, so the last step is each of these numbers that we've underlined, we multiplied them all together, and that will be our least common multiple. So we'll say our final answer is 20 times a squared times b cubed. That is the least common multiple between these two terms, 10ab cubed and 4a squared b squared. Okay, let's try one more example. Let's say we have the term 6x to the fourth y and the term 5x squared z. How can we find the least common multiple between these two terms? Well, once again, we're going to perform prime factorization on just the numbers to find the least common multiple between 6 and 5. So 6 can be broken down into 3 and 2. Notice that 3 and 2 are both prime numbers, so we're done factoring there. And then 5 can be broken down into 5 and 1. So now we want to write them in exponential form, so we could write this as 3 to the first times 2 to the first. We could write this one as 5 to the first, and we won't worry about the 1 since anything multiplied by 1 is just itself. So once again, we're going to identify each unique value, 3, 2, and 5, and choose the one with the highest exponent. Well, in this case, each number only occurs one time, so the least common multiple is just going to be 3 to the first times 2 to the first times 5 to the first. So that's 3 times 2, which is 6, times 5 is 30. So the least common multiple between 6 and 5 is 30. Okay, now let's move on to the x's. Between x to the fourth and x squared, the least common multiple is simply going to be the one with the higher exponent. So that would be the x to the fourth. Okay, now we can move on to the y's. So notice that y only occurs in this first term. There is no y in this term. So that means by default, y is simply the least common multiple between the y terms in these two expressions. And then notice over here, we have a z, but there's no z term in this first expression. So by default, z is the least common multiple. So we can write our final answer as 30. Remember, we chose x to the fourth, y, z. This is the least common multiple between these two expressions.